Okay, let's start the review for AP Stat Unit 1, Part 1 test. Okay, so first, who are the individuals? So the researchers collect information about 13 moose near their research station. They collect their gender, their height, their weight, how many hours each moose spends, and the water each day on average. Which of the following best describes the individuals and variables? So individuals definitely are not the researchers. So I think those answers are gone. Oh my goodness. We're down to B and D already. Okay, so the moose are what's being studied here, right? So there are two categorical, or two. So how many categorical? Um, Sex is definitely categorical. Height is usually quantitative. Weight is usually quantitative, measured. Those are measured variables. How many hours, time, on average. The fact they say on average tells me definitely quantitative there, the way they're treating that. So I think it'd be three, one categorical. It's got to be this guy. Okay, let's see. Table below shows the results of several candidates running for class president. Okay. Um, which of the following lists are all appropriate ways of presenting this data? So I guess you have to find out, is this categorical or is this quantitative data, right? Because that's the big thing. Um, it seems to me this is categorical, right? So if it's categorical, then which of these lists are all appropriate ways of presenting the data? So it's just one list of data, though. So it's not like side by side. I don't think we need a side by side there. Neither, no, that's what we need is those two things. I think it's got to be C. Bar chart and pie chart can use with one variable categorical data, so that's got to be it. Back-to-back STEM plots display the responses for freshmen and seniors from a large high school, but the number of tweets they posted in the last week. Wow, seniors post a lot more, right? 6.5 represents 65 tweets. Which of the following descriptions about the distribution of number of tweets made by freshmen and seniors is incorrect? Because it's hard to wrap your mind. You have to get incorrect. Seniors tended to tweet more with a median of 56. So you have to be able to find the median. Oh man, so it didn't tell me how many there are. 1, 2, 3, 4, 5, 6, 5, 6, 7. I count 20 freshmen, so I want the 10th and 11th. So this is weird. I think this is the number 8 and 9, and then 10, 11, 12. So that's 5, 6, 7, 8, 9, 10. I think these two numbers are actually in the middle, and that means the median is 14, because that's actually the stem is 1, and so that's 14. If you average 14 to 14. So that does seem right. Okay. Wow. One thing you might want to do instead of counting them all out and doing it, let's look at some of the other answers first. I have a feeling that's correct because at least half of it's correct. We'll see. The distribution of number of tweets posted by seniors is skewed to the left and single peaked. Seniors are skewed to the left. They're skewed towards the smaller numbers because that's 19, right? Kind of skewed towards that. So that's right. The distribution of number of peaks by freshmen is roughly symmetric and single peaked. Okay. I can do so. That one's correct. So that's not it because we want one that's incorrect. Neither distribution appears to contain outliers. So certainly not freshmen. I don't think seniors. I mean, that seems correct, which is not what we want. The variability in number of tweets is greater for the freshmen than for the seniors. That's just silly. The freshmen, very low variability, a lot of variability for the seniors. So this is got to be the right answer. And so I think we can eliminate A now. That must have been correct. I didn't do it, but you can figure it out. Mr. Cottrell asked the 26 seniors in his stats class how many AP courses they had taken during high school. Below is a dot plot summarizing the results of the survey. Okay, so what's the interquartile range? So I have to identify, to count this out. So 26, so I know that the 13th and 14th term are the median. So 1, 2, 3, 4, 5, 6, 7, 8. Wait, I have to count this out again. 5, that's 6, 7, 8, 9, 10, 11, 12, 13, 14. I think these two are in the middle. So right there is like the middle of the data. Best I can do. Okay. So 3 is the median. I don't think we need that, but I'm going to write it down. It's that particular 3. So there are 13 values to either side of that line that cuts it in the middle. So there are 13 values, which means the 7th term is the Q1. So 1, 2, 3, 4, 5, 6, 7. So this is Q1. 7th term going from the right would also be Q3 then. 1, 2, 3, 4, 5, 6, 7. That's Q3. So Q3 minus Q1 would be 5 minus 3 is the IQR. I don't know if we need IQR, but it's 2. I'm just finding stuff. Okay, what is the interquartile range? Oh, it's 2. That's it. A small company that prints custom t-shirts has 6 employees, one of whom is the owner and manager. Suppose the owner makes $120,000 per year and the other employees make $40,000 to $50,000 per year. One day the owner decides to give himself a $30,000 raise. Sounds good. Which of the following describes the mean and median salaries would change? So changing the highest number in a data set to make it much bigger, it's not going to affect the middle of the data at all. The medians can be very resistant to that. So I don't think the median would not change. So this one's wrong. Wait, the mean would not change. That's silliness. I don't think we need that. Okay, so it's either B or C. So how much would the mean increase by? There's different ways to think about this. So there's 6 employees, right? So let's average that. If you have $30,000 raise, well, how much is that per employee on average? That's 30,000 divided by 6 is 5,000. It's got to be B. Policeman records the speed of cars on a certain section of roadway with a radar gun. The histogram below shows the distributed speeds for the 251 cars. The max value is 35 miles per hour. Okay, that makes sense. If the value 35 miles per hour was actually 29, okay, how would the mean and standard deviation change? So I guess they're saying take this away and make it 29, which I think would go like right here. I guess that would go 1 higher, whatever it was. Not quite that high, but that idea. So, okay. So if you take an outlier and move it so that it's, well, it's still to the right of the median. So I don't think, oh, we don't care about the median. Sorry, it wasn't asking about median. So standard deviation is definitely not going to increase. It's going to get smaller because we took this. This has a huge effect. An outlier or potential outlier has a huge effect on standard deviation. It's going to make it go way up. But if it's closer to the mean, it's not going to increase. It's definitely going to decrease. So standard deviation will decrease. Standard deviation will decrease. Yeah, so I think we've eliminated, it's either B or D. So the mean would stay nearly the same. The mean would decrease. The mean's definitely going to decrease, right? So it's got to be B. Which following is not true about standard deviation. So I think of standard deviation as typical distance from the mean. Standard deviation is always non-negative. That's true. So which one's not true? So that one's true. That's out. Standard deviation measures the typical distance between the values in a data set and the mean value. Okay, I think that seems okay. If the units for the data are in inches, standard deviation is in square inches. Standard deviation doesn't really have a unit, right? So I don't think that's it. Standard deviation is very sensitive to outliers. That's true. Adding a value to the data set that is equal to the mean will decrease the standard deviation. That's typically true. Although if all the values were at the mean, it would just keep it the same. So you could make an argument that's not true. We don't know. It doesn't have to, though. I don't know if it has to be true, but it could be true. Could be false there. The following is a histogram that showing the actual frequency of closing prices of a particular stock on the New York Stock Exchange over a 50-day period. So what interval contains the third quartile? Oh man, so 50 days. So the 25th and 26th are in the middle, right? So there's all these numbers to the left and right of that, 25 to each side. So if there's 25 to the left of this, we want the 13th piece. That's Q1. So I guess the 13th piece from the right is going to be Q3. I'm going to count it that way. I'm assuming this is 1, 2, 3, 4, 5, 6, 7. I'm going to go to 13. 7 and 7 is 14. I think it's in here. So I think it'd be between 30 and 40. I'm going to check this one. I mean, I think I'm right. C. Oh, wait. I don't know if I answered the question. Yeah, they did. Okay. Yeah, that's it. Okay. Just want to make sure. A lobster fisherman is keeping track of the productivity of a set of traps he has placed in a favorite location. Below are numbers of the lobsters in these traps over the course of 12 different hauls. Wow. Big variation there. According to the 1.5 IQR rule, what are the values of the outliers? So let's just find there are 12 different ones. So between the 6th and 7th, 1, 2, 3, 4, 5, 6. That's the middle, right? Yeah. Okay, so the middle of the bottom half is this guy. That's Q1. Middle top half is Q3. That's Q3 is 7, Q1 is 3. So the IQR is 4. Q3 minus Q1 is 7. 7 minus 3. We like to see that little bit of work is 4. Okay, so we have to use the 1.5 IQR. So if you start with 7, that's Q3. So 7 plus 1.5 times the IQR, which is 4. So I think that 7 plus 6 is 13. That's the upper fence right there. And then 3 is Q1 minus 1.5 IQRs, which is 4. So 3 minus 6 is negative 3. Oh, that's weird. So way out here is the other fence. It's like the fence out there. So there's just one outlier, which is 14. Following box plot of birth weights, a sample of 160 infants born in local hospital. About 40 were below what value? Well, 40 is 1/4 of that, right? So what's 1/4? The first 1/4 or 25% of the data is between the minimum and Q1, 25, like a quarter. So below what value, whatever this is, what is that? 102? That's about right. Okay, I think we're to the free response questions. The states differ greatly in kinds of severe weather that affect them. The histogram below shows the distribution of the average annual property damage caused by tornadoes over the period of 50 years in the United States. Definitely skewed right. So shape, skewed right. Make sure you talk about the context, the shape of the tornado damage data, or something like that. So use context when you do this. Outliers, possible, outlier between 80 and 90. It's hard to write on this, so I'm just kind of abbreviating a few things. Center, usually the median. So if there are 50 years, so I guess you'd go to 25th and 26th, but the first 24 are there, so it's got to be in here between 10 and 20. Again, use the context between 10 and 20, average annual tornado damage, between 10 and 20 million in tornado damage annually. That's the median, sorry. And finally, variability varies from 0 to 90, or the range is 90, that kind of thing. Should read what they wrote. So 9 is, or 10, 11, I guess. The distribution of ranges varies from 0 to 90 million. Oh, I like how they put the units there. So I didn't really put it in millions. It's strongly skewed to the right. They even use the word strongly. This suggests many states suffered very little damage, but a small number of states suffered quite a bit of damage. Okay, we haven't gotten to part B yet. Okay. When asked for summary stats, Minitab got that out. So that's like all the stats you need. Explain why the distribution is strongly skewed to the right. Well, if it's skewed to the right, what should be true about the median and the mean? The mean should be bigger than the median. Is that true? Is the mean, because it's skewed right, the mean is greater than the median? Why is that true? So you want to give a reason why? Well, because the median is resistant, but the mean is very much affected by outliers. Histograms suggest they may be outliers, so what do we need to use? Well, fortunately, they gave us Q3 and Q1, so you could, 41.63 minus 2.23. Let's see if I can do this. That's not bad. 41 is 39.4 is our IQR. Okay, so you're going to do Q3, 41.63 plus 1.5 times 39.4. 100.73 is our upper fence. Our max is at 88, so that's not an outlier, I don't think. Why is that such a big? Did I do that? Q1, Q3, Q1's so small, so this is a really large IQR, I feel like. I don't know, I just didn't expect it to be so big. Q1's 2.23 minus 1.5 times, I guess, 39.4. Well, that's not an outlier. To show that no value, so let's just double check this one. So there are no outliers. They got negative 56 and 100.73. I think that might be the same two values we got. Yeah, those look familiar. Okay. So there are no outliers. Nothing's outside the fences. 50 randomly selected residents from state A and 50 randomly selected residents from B were asked the question, how many days did you spend at the beach this summer? Wow, so interesting graphs in that the top part is almost identical, pretty close. The bottom part, though, number of days, state B, they didn't spend just like a couple days, like they spent at least a week. How would you expect the mean amount of days at the beach to compare for the different states? Well, I tell you this, their median is the same. And I would mention that. Medians are the same. They're about 14. Medians for both equal about 14 number of days. Use the context somewhere. Okay, so man, they're both skewed maybe a little bit, but man, the A is way more skewed. So because it's skewed, the mean gets pulled. So the mean is going to be way smaller than the median for state A. I mean, they both might be skewed, but man, it's just more skewed. So I know that mean is smaller because of those smaller values that are part of the data. So I think that to answer the question, because of all that, the mean for set A is smaller than the mean for set B because that one's not as skewed, right? It's not going to be as out there. Let's see what they said for 12. Median values for state A and B are equal. The box plot for state A is skewed to the left, so its mean is less than the median. The box plot for B is approximately symmetric, so mean is approximately equal to the median. So the mean of state A is way less than the mean of state B. I agree. Very good. Okay. I put a couple. I think I won't have quite this many. I probably have like 13 questions on the test, but I just want to get extra practice problem in there. Might not be able to finish on time. I'm not sure on the review. All right, so 24 randomly selected NBA players were recorded. The data is given below. Use your calculator to find the mean and standard deviation of this guy. Okay, so add a list and spreadsheet, home key, go to list and spreadsheets, go up to the very top, type the name. I called it height. Take your time and enter all the data pieces in. I already typed them in. So make sure when you type that last one, press enter to get out of the cell. Maybe hit the home key, go to the calculator page, do one variable stats, menu 611, height, choose it, say okay. So I got to find the mean of standard deviation. So X bar is 78. There you go. X bar is 78.25. Whoops. 78.25. And we want the, we selected a sample. So using Greek letters like that sigma there is for population. S in this case is for sample. So this is the sample standard deviation. The sigma x is the population standard deviation. So this is 3.88641. Hopefully I typed in the data right. Let me just kind of double check 13. 3.97. Oh, I grabbed the one wrong. I don't know what I was doing there. I was looking at the wrong one. I said the right one, 3.S sub x, and then I just copied down the wrong thing there, 3.97. So I did type the data. I was just looking at the wrong thing. So are these values statistics or parameters? Well, we took a sample. Do you see where it says we took a random sample? They randomly selected just 24 players. There's a lot more than 24 players in the NBA. These are samples. So is this a sample? Sample statistic. So it's definitely a statistic because it comes from a sample. Population parameter, that's not what it is. It didn't come from the population. Interpret the sample standard deviation in context. 3.97 is the typical distance, probably. What is this? Typical distance from the mean height of NBA players. From the mean height of NBA players. Let's see what they said for 13B. The height of the players typically varied by about 3.97 inches from the mean height of, and they even mentioned that 78.25 is the mean. Suppose two players were added to the data, each with a height equal to the mean. Would this have any impact on standard deviation? Well, equal to the mean has standard deviation of 0 for those two players. So like, yes, it's going to make the decrease because there's less distance from the mean, right? 0 is not a lot of distance from the mean, right? So this is 13C. The new values would have a standard deviation of 0 for the mean. Because the standard deviation is a measure of the average deviation, it would be reduced by 2 more zeros in the calculation. Yeah, you'd have some more zeros in there. Okay. Last question. Parallel box plots talk about the number of virus alerts generated by company computers that text departments at two companies over 24 hours. Compare the distribution of virus alerts from the two companies. Okay, so you want to talk about shape. So for Pearson, the shape is skewed right. For the T company there, that's shape is, and you could almost say approximately symmetric, but I think it's more skewed right as well. Let's see what they said for 14. Oh, they said it's roughly symmetric. I could probably go both ways there. I definitely see that roughly symmetric. Sometimes I take two different answers. I can take two. I would do that there. Okay, outliers. No outliers. They're all connected box plots. Can't. I mean, this is tempting to be an outlier, but if you go about that distance to the right plus another half, I think the fence is out here. So I actually think it's not an outlier, and it's drawn that way, so it's not an outlier. So no outliers. Center. So the median for the turkeys, turkeys like St. Mary's, median for turkeys is greater. So median for turkeys is greater than the Pearson. Okay, I'm just not writing it all, but it's there. And then finally, variability. Oh man, Pearson has much greater variability than the turkeys do. You can say it goes from 45 to 120. Turkeys only go from about 60 to 82. Does it appear if one company tends to receive more virus alerts than another? Well, good question, actually. You might can make an argument either way. Tends to receive more, so more than the other. Let's see what they said here. There's I think a couple different ways you could go with this. Because 25% of the virus alerts from Pearson are greater than any of the turkeys, it would appear that Pearson tends to get more. So, yeah, if you think about it this way, it's definitely one way of going here. 25% goes from here to here. Well, all of that is greater than the biggest one for the other guy, for the turkeys. So, yeah, you'd have to say that. Even though there's a lot that are lower, that's why I'm like, yeah, you can make an argument at least. Interpret the interquartile range for Turkey. So Turkey's interquartile range is from there to there, like, I don't know, 75-ish minus 62-ish. 34-ish minus 62. About 12. So 12 is the number of alerts, I guess. Let's see. The range of the middle half of Turkey virus is 12 virus alerts. So the middle half of the data, the range in that case, the range of the middle half of the data, I guess. For each company, determine how the mean will compare to the median. Well, this one's skewed. So for this one, you're going to say the mean is greater than the median. This one is approximately symmetric, so the mean is approximately equal to the median. Sorry, so sloppy. explain, so you might want to explain more about the context. Again, the reason, because it's skewed to the right, mean is bigger than mean, roughly symmetric, means are about the same. Okay, that's your review and recap. If you need to go through that, there you go.